Welcome to another video. In this video we are going to find out the rank of a matrix using row reduced echelon form of that particular matrix. So the theorem we will be using here is that if a row reduced echelon matrix have r number of non-zero rows, r number of non-zero rows, then the rank of that matrix will be r. The rank of that matrix will be r. So if there are r number of non-zero rows, then the rank of the matrix will be r. So we are going to use that theorem. Well, let us take a matrix, for example a 4 ordered matrix. The first which is 1 2 1 2 1 0. The second row is 2 4 8 6 2 4 8 6, and the third row is 0 0 5 8, and the fourth row is 3 6 6 and a 3. Well, this is the matrix. What I am gonna do here is I will apply row operations to this matrix so that I can maximize the number of zeros and minimize the number of non-zero rows. That's what we gonna do here. Well, in order to do that, we will have to apply various row operations. As for the second row, I can observe that all the elements of the second row are even. So let us divide the second row by 2. So the first row operation I am gonna give here is dividing the second row by 2, well, half of r2, and I can also see the fourth row is a multiple, are multiples of 3. So I will also divide the fourth row by 3, the fourth row by 3. So I am going to give 2 row operations here, as you can see. Well, the first row is divided by half, divided by 2. Well, not the first row, the second row. Well, the first row remains same, 1 2 1 0, 1 2 1 0, and even the third row remains same, which was 0 0 5 8, and the second row is divided by half. Well, the second row becomes 1 2 4 and a 3, and the fourth row becomes, after dividing by 3, it becomes 1 2 2 and 1. So this is the form, and I am going to give more row operations here. Well, see what gonna be the next row operation. Well, I subtract row 4, I mean the fourth row, from the second row, This is the row operation I am going to give here, and I am also going to give another row operation, which is, well, let us first do this operation. Let us concentrate here. Well, the first, after giving the row operation r2 minus r4, the first row remains same. So let me copy the first row first, 1 2 1 0, and the second row changes, but the third row, nothing happens to the third row, 0 0 5 8, and the fourth row also remains unchanged. Well, I only change the second row here. Now the second row, row 4, I mean the fourth row is subtracted from the second row, so it becomes 1 minus 1, which is 0, 2 minus 2 is 0, and 4 minus 2 is 2, and 3 minus 1 is 2. It's 2, not 1, it's 2. Okay, this is the form. Now I can apply the next row operation, which is, I can see that in the second row all the elements are even, in fact 2. So I divide the second row by 2. This is the row operation I'm going to give. Well, let me write the row operation in the next line. So it will be half of R2. It will be half of R2, and that will be, well, the first row remains unchanged, so I copy it. The second row becomes 0 0 1 1 after dividing by 2. The third row remains unchanged, 0 0 5 8, and the last row also remains unchanged. It is only the second row that have changed. Now let us again observe what can be done. Well, if I subtract row 2, if I subtract row 1 by row 2, will anything happen? Well, that's of no use. Let me subtract row 3. That's the operation I'm gonna give. Well, let us revert back and subtract third row. Subtract second row from 5 times the third row. 5 times the second row. I'm sorry. I'm subtracting the third row, and I'm giving the operation R3 minus 5 R2 basically. So it's I'm subtracting 5 times the second row from the third row. So this becomes 1 2 1 0. The first row remains unchanged, and the second row also remains unchanged. Now if I subtract 5 times the second row from the third row, so the third row changes and it becomes 0 0 and 0 and 3. Then and the last row remains unchanged, like 1 2 2 1 1 2 2 1. Now what I am going to do is divide the third row by 3, because I can see there is only one element, which is 3. So giving the row operation 1/3 of R3, the matrix becomes 1 2 1 0 0 0 1 1 0 0 0 1 and 1 2 2 1. So this is the reduced form. This is the reduced form, because I have only applied the change to the third row. Okay, the third row. Now what I am going to do is I can subtract the fourth row. I can let me give the row operation like R4, the fourth row. I'm subtracting the first row from the fourth row, R4 minus R1. Then it becomes, the first row remains unchanged, so the first row I am copying. Second row I can also give another row operation. I can give the second row. I'm subtracting the third row from the second row, so the second row also changes. It becomes 0 0 1 0, and the third row remains unchanged, 0 0 0 1. Now talking about the fourth row, I have given the row operation R4 minus R1. So R4 minus R1, the elements become 0 0 1 and a 0. So I can see here, after giving the row operations, the third row, the second row and the fourth row are equal. So I will subtract the second row from the fourth row, and applying this operation, the fourth row will all be gone, reduced to 0. All the elements will become 0. So 0 0 1 0, and the third row remains unchanged. Well, the fourth row vanishes, 0 0 0 0, and I can see there is nothing more I can do, except for the fact that I can subtract the uh, second row from the first row, I can subtract second row from the first row. Okay, I can apply this row operation. Well, after applying this row operation, the new form matrix will be 1 2 0 0 0 0 1 and a 0 0 0 0 and a 1, and the fourth row will remain 0. The fourth row will remain 0. Now let us observe this matrix. This is a fully reduced row reduced echelon matrix. Now observe the number of non-zero rows. This is a non-zero row 1, this is also a non-zero row, this is also a non-zero row, except this is the zero row. All the elements are 0. So number of non-zero rows of this row reduced echelon matrix is 3. This tells us that rank of matrix A is equals 3. So this is how we can find out the rank of a matrix. We can reduce the matrix to its row reduced echelon form, and we can count the number of non-zero rows. Here it is 3, so we can conclude that the rank of the matrix is 3. I hope you have enjoyed this video. Please, if you have come so far, please give a like and please do subscribe my channel. I will be posting more of such interesting contents. Thank you so much.